Good afternoon. My name is Bart Soede. Welcome at the second webinar of our PIAS presentations. In this case, we'll be discussing some of our future development. I should explain a little bit on that because some of these developments are on the way, but it will be in the near future that you will be made aware of them or be able to use them anyway. So that's what we'll be dealing with. It's I'll show you the topics there. These are the topics for today. So Uniload integrated module for all types of cargo, second generation, etc. Well, you can read it all there, of course. So let's slip into the first of our further slides. There will be 9 or 10 slides again, so it will not take us out of half an hour. I think it will be a bit shorter this time. But now for the first topic, Uniload. For PIAS and LOCOPIAS, and particularly for LOCOPIAS, we have created quite a few modules to define cargo with. And we started that in the DOS age, and that has grown and grown and grown. And basically we defined a new module for every different type of cargo. We are now in a place where we can actually integrate all of them, and we will. So we are now working on a shared storage of all types of cargo, and that means that it's easier to draw them and that we can do a clash control between containers and general cargo, that we can pick up a container in the crane module, etc. And that was in theory possible in the past, but in practice not so easy because they had different storages and whatever. That, yeah, you could consider that that's a remnant from our past, basically, because in the past we didn't have simply the capacity. The computers were not strong enough to accommodate for all of that, and that has been a while back, but it's a huge task to integrate all of that, and we are working on that as we speak. So that is what is being currently done, and you will of course find that in the future within your PIAS and LOCOPIAS menus. There will be a generic data structure, which also means that it will be easier to read data from different sources to define different types of cargo. So BAPLI is a common file for containers, but STL file is common to exchange shapes of things. In general, it's stereolithography, so you can actually print an STL file to your 3D printer, but it defines the shape, so we can also use that kind of files to define a shape to every bit of cargo we may have on board. Of course, for a container it's fairly easy, the shape is known, typically rectangular, but for more difficult shapes, and you might think of parts for windmills at sea, basically any kind of cargo that is not square, that will be easier to be defined in the new setup. We will have rule-based generation of container slot. There will be more about that. That's actually the lower one, so I'll switch the camera to the top there. And rule-based means that if we define a grid of fittings for containers, then the rest of the containers will be automatically added. The rest of the container slots will be automatically generated by placing any new container, etc. So there will be quite a huge step forward for us in configuring all these modules and integrating them further and drawing them on in the same fashion in multiple screens or in the same screen even, etc. We are working on that. It's a huge task because, as you can see, we have developed quite a few of these modules, and we are now streamlining all of that to make it more usable and more user-friendly. So that would be my description on Uniload, and on to the next slide. I should pick the right window first, otherwise nothing happens. Second generation in-text stability criteria. That has been hovering over the market, so to speak, for quite a while. Many publications on that, many studies, and now IMO have come to a common understanding of what these rules should look like. we already offered a scanning for these criteria to our clients for their current models and the current projects to see whether or not their vessel would withstand these criteria. And we did not implement a complete package for that, basically because nobody has asked us yet. But if the second generation criteria will take a high flight, that's actually a Dutch translation, but if they come into play, then we will have a suitable module in no time. We can do the different bits and pieces of the required calculations already, and we will integrate that into a nice module if that is being asked of us. But so far nobody has asked that. Then that's enough on that. You can even find it on our website. If you go to the company section and then the news, you can actually search for, let's say in this case, scan. That's what we offered in 2017. So that is part history and part future of PIAS, because we will implement that in a nice module as soon as market demands. Then the Voyage concept in LOCOPIAS. Currently in LOCOPIAS, everything is focused on a single loading condition. And if you want to plan a voyage ahead, then you just simply define a number of these loading conditions. But there is, of course, a relation between these loading conditions. We have baptized these relations interventions. Basically, you start somewhere, and during the trip, you use fuel and drink water, and you will possibly take on some containers in the next harbor, etc. These kind of interventions can be defined, and thus we can generate a series of loading conditions which are linked to specific steps in time, or at least have their following order. We can then, if we have that, use optimization techniques. We have quite a few of those already for positioning containers and for row cargo, etc. We can combine them, and that's not ready yet. That's actually future concepts in PIAS. But then you may optimize your entire trip for reduced ballast or optimum trim, drawing up an outlook in the direction of a speed advice. So if you know that your next harbor, you can reach it in 2 days or 4, and likely you will use less fuel if you do that in 4 days. So you may optimize the entire trip by using these optimization techniques, and we are working towards that. That will not be ready anytime soon, but that is the way we are, well, focusing our development efforts. Then, a transpiler to D. Since 1982, we have been using Pascal, and that's still completely a valid language. People say, oh, it's so old, but well, never mind that. You can basically program anything you like in Pascal, and we have, but we think we should upgrade or update our language that we program in for a number of reasons. It will give more long-term certainty because the number of Pascal compilers is well, growing thin, and D will likely be a bit quicker than Pascal implementations, and there is a large user group supporting D, and it's a decent language. And one of the benefits we found is that we can actually implement a transpiler, which is a translator for code. It's not that easy. It's not a simple reformatting of your text. It will involve some more things, and we need to do that because we have some 500,000 lines of code, and we're not going to redo all of those. We're not rewriting our program. We are developing a transpiler to automatically generate D code where we used to have Pascal, from Pascal actually, and that will never work in full. Some features in Pascal are just simply cannot easily be translated, and if this feature only happens once in our software, then it's more easy to, or quicker, to just reprogram that in D, then make a huge effort to compile, to translate that automatically. So it's a bit of a, well, continuous development, and we have programs running that were compiled in D, but well, we are getting there. Every next program will show a few more issues that we have yet to solve, and possibly rewrite bits and pieces. And lookup D, it's the only question that you can raise on D is why isn't it used more? It's really, we were glad to have found it. You will not, as a client, not notice a lot of it, except we wanted to share this anyway because it will tell you that we are preparing not for next year, not for the time to come in 3 years, but this will be a requirement that we will benefit of for the next 20 years. So we're not here to, our horizon is a bit further away than the next year or the year after. We look quite a bit further ahead with this. It's a huge investment, it's a huge effort, but we think we must do that. Okay, then the next. Actually, I'm going a bit quicker than I thought, so this may be a shorter webinar than the previous one. I hope you don't mind that. We are implementing a ship motions program. That's not really something new. Yeah, for us it's new, but many of our competitors have it, and it works well everywhere, and it's not that difficult. There's good literature available, and we can validate the results quite easily. And then we will make the acronym of our PIAS name, which is the Program for Integral Approach of Ship Design, a bit more true if we can do ship motion calculations. The processing times are very reasonable, it's quite fast, and people know it because, well, it's in use by most of our competitors who have something similar. The use of this may be not only to see whether your passengers will get sick or so. You may think ahead and possibly use this to define the lashings for containers or make some further investigations on actual sea states and actual circumstances and see whether or not you can still use your equipment on board. And that may be fitted into LOCOPIAS as well. So that's future plans. We will see how far this will take us. And that will not take years before we have a ship motions program to have it implemented in full in any place that we can think of. That may take a bit longer. So if you've got any good ideas on that for purposes that you want to use this kind of software for, please give us a call. We're always looking for good ideas there. And the next slide. We're already at 7, so it will be a brief one, this one. Container cargo optimization. Container planning is always a tedious job if you want to do it right anyway. You want to carry as many containers as you possibly can and with as little ballast as you can. And you can do that manually, of course, but for larger container vessels that will be a bit tricky. You can define some specific goals for an optimization. The number of treatments of containers, so you don't want to have the containers for your next harbor on tank top, because then you need to remove all the other containers from it before you can access them. And there is an optimum trim and draft, and of course there are some further constraints such as stability and strength, etc. The ones you see there. IMDG, which is a separate subject in a future webinar, because we have implemented quite a nice option to check on the IMDG requirements, which is available, but that takes us outside the scope of this particular webinar. Line of sight, maximum draft and trim, yeah, we can do all that. And in combination with the the voyage planning, so generating loading conditions for any vessel, for any trip actually, including containers, this is part of the optimization techniques that will be implemented there. It's quite a job actually. You can see in the right hand screen already a preview on the IMDG. There's a container, and apparently that one, I hope it's visible on your screens. It's quite nicely visible here. There may be a conflict on the substances carried in different containers, but that's a subject for a future webinar. Then, yet another slide. Damage cases. We are working towards that. We are reprogramming actually the calculations we have for damage stability in prop dump loading and hydro tables. Hydro tables would be maximum allowable VCG tables. Loading would of course be direct damage stability calculations. And probabilistic damage stability is of course the massive calculation of immense numbers of damage cases that you are likely aware of. And because they were separate modules, the storage of these damage cases has grown a bit separate because different things were required for different calculations. We are now merging that all, and as a goal and a side effect of that, the storage of damage cases will be identical once more. They used to be identical. PropDom was amended for some further features, and they will be these features will be completely obsolete by one of the topics of the previous webinar, which was the inclusion of piping in our software so that we can predict progressive flooding. And the extension of progressive flooding has caused the damage cases to be, well, slightly differently stored for the different modules. So we are working towards a cleaned up version of PIAS, if you may say that, where we can do more with less. That's basically the idea. Less different storage of different things, less different storage of weight items. That's been done in Uniload. Less difference in damages because that's all integrated in a single library of stability calculations. Actually, it will be more or less identical to intact stability calculation, but then without damage compartments, of course. And we are integrated all these bits and pieces, and you will notice the effect in due time because things may look a little different. Some results may, well, deviate ever so slightly in the so many decimal, because reprogramming that will affect some of the iteration procedures we use, and you may see some effects of that. These were the topics for now. I will yet show you our website to see on the second generation of intact stability criteria. I'm actually on the news section here. If I go to the previous one, we're now skipping through all these different news items. There we go. This was the last one, actually, the announcement of this webinar. But if I just here click Control F and search for the scan, there we have it. Second generation intact stability criteria scan. And already in 2017 we were preparing for that. And since then nobody has asked us to do this, and we therefore have not defined a specific module for that. But if you want to check the results, please go to the news site, the old news in this case, and there is a leaflet there with more details, and that will show you on what we have done so far and what our plans for the future are should anybody ask us. That's it for me for now. Please send further questions by email. I didn't check on the chat window now. I do not have it open, actually. That's a mistake on my side. I will correct it for the next session. The next session will be second week of August, the 6th, if I'm correct. We will send a further email, and please check our website because further data will be announced there. That will be after summer holidays. We hope to see you then. The next one will be on fairway and related issues, hull conversions and whatever. That's it for me for now. Thank you.